Drexel, joining undergraduate and graduate students, because all our graduate students here work very closely with undergraduate students. So I think it's a good match, and it's my pleasure to introduce Dr. Mira Olson, Associate Professor in the Department of Civil, Architectural, and Environmental Engineering, CAE. I know, they all say CAE, and so welcome, Dr. Olson.
Good, thank you. So I'm glad to be here, and I'm not going to spend much time because I want to get the students up to talk. So we have two speakers today. We'll start with Nick Barber, who is a geoscience teacher, is that right? And he's going to talk about sediment transport along barrier islands in the Delaware Bay, but I've also learned that he's working, or has worked, or is working on a number of different research projects, so we'll hear about those as well. And after Nick will be Don McDougall, who is going to, I'd like to hear about her major. It's a custom design major in sustainable urbanism, so perhaps we'll learn a little bit about that. And she's going to talk about meaning creation for city dwellers. And so I think what we'll do format-wise is they'll both give short presentations. If you have any clarification questions right after they're done, we can do those. And then we'll have a discussion of both the talks when they're done. So, Nick, please.
Hello. All right. So I think introduction is part of the day, so I'm going to roll right in. So the project I'm going to be talking about today is a smaller component of my mentor's PhD thesis. The project as a whole is a historical and geological survey of barrier islands in the Delaware Bay, and more specifically, how these barrier islands, which I'll define that in a minute, you can picture what that is in your head right now, how these islands respond to sea level rise. That's really the main goal of our research, is to understand how they've responded and what they're going to do in the future. And we're getting a pretty good understanding of that now, sort of as the state of research. And going forward, what we want to be able to do is take this understanding that we're developing and integrate it into a computational model that planners can use to better prepare denizens of southern New Jersey for the inevitable effects of climate change. So this brings me to my part. My side was primarily geological study with a little bit of statistics thrown in. I basically looked at grain size distributions, which will make a little bit more sense in a minute. But this is basically just a description of the amount of grains of a particular size in the sample, and that value is really dependent. And using some pretty simple statistical tests, figured out the long-short current direction, at least an idea of where the current's going and what kind of energy is associated with these processes that are shaping the islands. That's the overall drive of the project. And the islands that we worked on, so just as I said, I will define the term barrier island. If you've been on LBI, Long Beach Island, Assateague Island, the Outer Banks, these are typical of the average open ocean barrier island, which is what real estate developers love to work on and what people love to vacation at. And these islands, despite there's about 2,200 in the world, they actually make up a smaller percentage of global shoreline than the islands I worked on, which we would call fetch limited. And this just means that they're in a sheltered, low-energy environment and have really limited sediment inputs. They just don't have the raw material to build themselves up and make themselves larger like these open ocean cousins. And until recently, you can see this map down here, sort of outlines where they are in the world. We were right here. They've been almost completely understudied, and only in the past few years has anyone really looked at them scientifically and economically as an option for development. And that makes it all the more critical that we start researching and understanding these islands. That's one reason we decided to pick this lovely study site. It's about an hour and a half southeast of Philadelphia, just north of Cape May Point. And our study area focuses, this is the overall study area, but we mainly looked at islands from about there to there. We looked at 4 islands. And as I said, just looking at this map, you can see these are the islands right here. These tiny wisps of sand that are just sort of clinging to the coastline. And they're about a kilometer long, maybe like 10 meters wide and like a few meters deep. They're really tiny. And looking at this, you might ask yourself, why would you care about tiny stretches of sand like that? Because, I mean, they really do seem sort of insignificant in the grand picture of southern New Jersey. But from an ecological standpoint, these islands are really important. And that really comes into play when you consider that the Delaware Bay is one of the largest stops for migratory birds in the continental United States. And this is largely due to another endemic species to the islands, the horseshoe crab, which are starting their spawning ritual actually sometime in the next month. They're going to start going up on the beach and providing food for migratory birds. In addition, the islands support terrapins, piping plovers that we see here. And so the islands themselves are really important from an ecological standpoint. But even more important is the fact that the islands are part of a system, the Bear Island Salt Marsh system. And the salt marsh, if you remember the picture that I just showed, the salt marsh is this whole area stretching back about that far. That's roughly a kilometer or so. And that salt marsh exists because of the Bear Island. It's able to stand up to the wave energy activity. And that's exemplified by this picture right here. On the left and on the right, you see there's a pretty stable Bear Island standing up. And you see that the marsh behind it is healthy, going back pretty much as far as that can see over here. But in the middle here, in the foreground, you can't see it. The ocean is right over here. It's cut a path through the island, forming an inlet. And where it cuts into the marsh falls away and desiccates. And so the reason we care about these marshes is because they're some of the most important biodiversity hotspots in the northeast of the United States. In addition to the fact that together the Bear Island Salt Marsh system act as a huge buffer zone and shock absorber for wave energy. And so when you're looking at a huge storm coming through the Delaware Bay, you're grateful that you have this system here. And so our main concern really with the effects of sea level rise on Bear Islands, to sum up, is that if we lose these islands, we lose these salt marshes. If we lose these salt marshes, we don't only lose precious biodiversity hotspots, we lose a really critical service, ecological service that provides us with protection from waves and storms. So that's the reason in the end that we really care about these islands. And now that I've maybe scared you a little bit, I'll go into some of the details of how I actually went about this. So we would load up early in the morning. We would go out to these islands by boat. In every case, no road was able to get us there. So some days we had the fortune of using motorboats sponsored by the Academy, and some days we would have to set off in a canoe, and the canoe would open Delaware Bay at high tide for about a kilometer or so, with 50 pounds of gear. So those islands were especially fun, and I got a great work out in grade 10. So we went, as I said, we went to about 4 islands that you'll see in a moment, and we gathered in total roughly about 500 samples, which is pretty good for this kind of study. And 80 of those, the ones we're going to be talking about today, are surface. The rest are subsurface. And if you want to know more about the subsurface analysis side of it, you can ask me afterwards, because it's sort of complicated and we're not really dealing with that yet. But so the 80 I'm going to be talking about today, we would bring back, we would dry them in the little packets, and then thanks to the generosity of Temple University, we would bring them to Dr. Ilya Winovich, who has this lovely machine, the cam sizer. And this is an actual picture of the cam sizer. It basically uses lasers that target the individual grains as they fall past this white background. It estimates their size, their shape, all sorts of statistical parameters regarding the entire sample. Which just, I mean, that type of work to get that kind of data used to take a stack of sieves as tall as me that you would shake or have something shake for hours. So, I mean, if it wasn't for this cam sizer, we would still be doing this analysis. So, I mean, it's great that we're able to use that. And what this would give us is basically a curve on Excel, or in the cam sizer itself, that describes the frequency distribution of grain sizes. And as I said in the beginning, there's a reason that we do this. And the main reason is that these grain sizes are proxies for energy. And that's sort of an intrinsic fact if you think about it. If you think about this water bottle compared to this podium here, it's going to take less energy to move a water bottle. You can just sort of imagine that in your mind. And the same principle applies to the grains. They're all basically quartz. They have the same density. So a smaller sand grain requires less energy to move than a big sand grain. So if you find a pile of pebbles, you can guess that in that particular part, waves have been hammering it pretty hard as compared to the finer part. And when you look at that energy distribution across a region, when you look at multiple grain size distributions across this whole area, you can get an idea of the gradation of energy as you move from point A to point B. And so that's the real value of what we're doing with these. And again, stratigraphically just means subsurface. If you want to ask about that, it's complicated and that's sort of at the cutting edge right now. We're not even really sure what to do with that third goal. But one day we'll get there. And fortunately, this brings me to my islands. So the first island that we're dealing with is the westernmost, and it's also the smallest that we're talking about today. When I describe the trends, I'm going to be moving from A to B, or in this case, west to size across 10 transects. And as we move from A to B, west to east, we see this fining trend, especially exemplified in the landward edge. And when I say landward edge and high tide line, the high tide line is basically the ocean side, and the landward edge is basically the marsh side. So this blue here represents the marsh. And as we move from A to B, we're seeing a decrease in grain size. You might look at this graph and be a little confused because the bars are getting taller as you move from A to B. And that's just because the unit that we're using, phi, is just a negative log transformation of our arithmetic. So this 0.75 is coarser than a 1.5 phi. Basically how it works. It's like pH, lower pH is actually higher nitrogen concentration. So that makes the display a lot easier. And when you look at sorting, which is basically standard deviation, it follows a pouring trend. As we move from A to B, it's getting poured. And when we look at skew, which is a statistical measure, it's generally negative, which is constant across the whole region, which is good. At least the cam sizer is giving us consistent, error. At least that's and so in general, we're seeing this finding in this poor trend as we move from A to B. And what that tells us, as I said, as a gradation of energy, is that as you're moving from A to B, you're losing energy. And so you expect that there's actually a current just offshore that's transporting sediment from A to B. This is sort of the ideal thing you're going to find in coastal geology. This sort of trend, as you'll see in a moment, gets a little more complicated as we move on, but that's interesting to see. Another thing to point out is I just glanced over, and it's just kind of cool. Right here you see this spike of coarseness, and unfortunately the resolution on this picture isn't great. But just for that transect, which is roughly like right here, there's a little patch of plants that's just sitting in the middle of the island. And when waves reach that point, the plants sort of trap the waves, decrease the energy, and all the heaviest stuff gets dropped out, all the biggest stuff. So that's why we get this spike in coarseness. And that principle of slowing down the waves is going to be important in just a minute. So that's just something cool to know, how the effect of vegetation can impact the building of these islands. We get to island 2, which was probably the biggest island we looked at, and unfortunately I cannot talk about that today because our nomenclature that we use for the samples is sort of confusing, so we haven't had time to sort that out. But we are getting it. Fortunately, we still have Island 3 and 4. And Island 3 starts to exhibit a trend that, again, we're really happy to see. And that's namely that, again, we see this, especially at the high tide line, we see this spiking trend as we move A to B. But even more important, and we also see another poor trend, which is good. It looks like energy is gradated from A to B, in this case, north to south. But what's even more important, if we go back to the mean grade line, is that the average for Island 3 is much coarser. It's going from negative 1.7 up to about 0, as compared to about 0.7 to 1.5 on the other end. So that even though it seems like the same trend is being exhibited, there's a higher coarseness here, which initially perplexed us, but fortunately there's an idea out there as to why this is happening, and that's due to wave energy. So as I said, waves are really important issue with these islands. And as you move further south, as you're moving closer to the mouth of the bay, you're getting wave energy input from the open ocean, from the Atlantic Ocean. And so the Island 3 being further south than Island 1 would hopefully exhibit a much higher wave energy regime because it's closer to the source of that energy. And that's a trend, and another important thing that will sum up in the end all the other trends we'll see. And it would be nice now, Island 4, we would like to see an even coarser island. We would like to see a fining trend. We would like to see a trend towards poorer sorting. And that's not what we see. Island 4, we see this mess. And Island 4 was, I don't even know what happened. There's a few good things to note. First is that we have sections. From Island 4 to about 11, sorry, transect 4 to 11. We have a coarse section from 12 to 19. We have a fine section, roughly. So there's at least some units that are consistent, but the island as a whole exhibits, there's no trend. I mean, it's a mess. And the sorting is basically the same. Maybe you could argue it's getting less bad, but it's a mess. And so the skew, fortunately, is negative. So that sort of initially we were like, oh man, what does that mean for our theory now that there's a current moving from island 1 to 3, from west to east, now north to south? What does this mean for that? And fortunately, we have an explanation that comes in the form of a letter covering it. Right here, there's a spit coming out. If you've ever been on a beach, you've seen a jetty or a spit. It's basically just a pile of rocks or some sort of structure that coastal engineers put out. And what it does is, like the vegetation that I talked about, it stops the waves and forces them to dump all their sediment. And that causes a building effect. This island here used to be eroded. But about, I think, 30 years ago, they put this spit in here, and this island's been building out dramatically. So that means a few things. First of all, that means that there was a current that was moving northwards, that was going and delivering sediment from here to here. It was moving out this way. And they've disrupted that with this spit. So that means that there's not just this one current that we're seeing. That means that there's multiple currents, which is what that's not atypical in these systems. But that means we're doing a lot more complex of a system. And in addition, that also implies that that current that was once moving northwards is now sort of not only just mixing with the current I described from Island 1 to 3, but is being deflected by the spin, which might be an explanation for the high variability. And in addition, the fact that we're moving further south of Island 4, you're also getting a higher input of wave energy, again, dealing with that idea that I threw out there. So not only are we seeing multiple currents, a deflected current, and high wave, those are the three things. Two currents, a deflected current, and high wave energy. And that, I think, is going into explaining why we're seeing not only this trend as we're moving towards Island 4 of higher coarsening, but also this higher variability in Island 4. So just from picking up, basically, a lot of that might seem kind of odd, and stuff I mentioned. What I want you to take out of this is that I basically spent my summer walking on the beach. I picked up sand, put it in a bag, and everything I just told you was from that. So that's really the value of what I'm talking about today. And this isn't done. This is an ongoing project. We are still meeting with people, lots of coastal geologists, to tease out the details to finish Island 2. Another thing we want to do is start looking at the cores, so the subsurface work, which again, if you have more questions about, I can answer in a moment. And the other thing that we're doing, hopefully sometime soon, is mapping out the actual wave energy. As I said, we're hypothesizing that there's higher wave energy as we move south. But we want to confirm that by using NOAA wind data. We have a great database of that. So we're going to be using some ArcGIS programs to map out the direction and the energy of prevailing winds to confirm that idea. So that's pretty much everything I have today. My general acknowledgments. I just, in particular, want to thank Anna and Dr. Rivera. They were mentioned on the first slide, and if it wasn't for them, I wouldn't be standing here, I wouldn't be the student I am today, or the aspiring scientist. So, yeah, thank you.
Are there any questions for Nick before we move on? Oh, please, go ahead.
So, with your camp sorter, can you use that to see if there's, in other populations, other land areas, if there's deforestation happening? So can you use the grain size and the skewness that you've shown today as a model for understanding if in some other part where there's a rainforest, there's a lot of deforestation happening, can you look at those samples and say this is what's happening there?
If that analysis depends on size, even the type of, even if you want to know what the type of sediment that's falling past it, the camp size can do that. If your goal is to understand the size distribution of the rainforest sediment sample, then the camp size is the perfect one for that. Is that your question?
Yeah.
Okay.
I mean, how reliable is your study using this island study? How reliable is it to use it as a model for other?
Oh, you mean like this study in total? We're not sure yet because we haven't actually built that model. Really, we haven't really done the statistics yet to prove that this is a good model. So I wouldn't be confident saying that we can use that.
It would really be focused for this region.
Our goal is
No, so it doesn't mean you couldn't take similar, you have to plug parameters from other regions. But building the model, then you have to have the specific parameters for each region. And it would be limited to affect limited environment. It's really calling side of it.
Oh, that's fine. But the general concept of using the grain sizes as a proxy for energy and relating that to deforestation or whatever, that's a concept that can be applied anywhere. And then actually, camp size is mostly used by pharmaceutical companies to make sure that the drugs are all the same size. So that's actually what its main use is for. We need to sort of appropriate that with those.
So as far as I can see, you're basically presenting your observations on what you collected from these islands.
Yeah, that's basically.
And you mentioned that it's very important to have these islands there to protect the inland and all of that. Do you have any recommendations for, I don't know, the Coast Guard or coastal engineers to protect these islands based on what you observed in here? Like you said, like sometimes they drop these concrete things, so
Yeah.
new islands form there.
So, I think in general, at this point, again, because this is still such an early stage, I can't say that I could give a recommendation to the Coast Guard that would be, accurate enough to address that. But in general, what I'm doing here is basically just establishing, because we don't even understand the current direction as I was talking about. We don't understand any characteristics of this region at all. No one's ever studied this region. So the main goal of this would be when we do eventually return to the Coast Guard, we can say, here's what the currents are doing, here's what the islands are doing, and based on that, here's what we can do. We haven't gotten to that third step, though. That's the critical next step. So, yeah.
Is it possible to take any kind of measurements of the water itself that would give you an idea of the direction that it's moving?
For big studies, for big coastal studies, that's what they do. They have basically flow meters that measure the velocity. We didn't really have time or the resources to do it in this study, just because we would have been running out to get sediment samples and running into the ocean and going down. But we're hoping that the NOAA wind data that we have, which is public access, and literally just like a couple miles off the shore, we're hoping that's going to be a proxy for what at least the surface waters are doing. So that'll be an additional data input besides the sediment stuff that I talked about today.
Good. So I think we'll move on. I do want to commend you for not only presenting the complex data, but also motivating for us the importance and the connection to the larger scale issues, which is exactly what we're trying to do here. And that's the critical step in connecting all these levels. So both for the climate change of the sea level rise and also the connection to the ecology. So I'm really impressed that you were able to do that. So thank you. Next we will hear from John McDougall, who will present on meeting creation for city.
So I don't know if my clicker is still alive. So I'm going to give you a really lightweight presentation to help focus on less on the project itself and more on the process of doing undergraduate research and doing it in an interdisciplinary way. Design major, and my major was eventually titled Sustainable Urbanism. It wasn't always titled that. I'd like to emphasize that it was very much a journey and a process, and part of doing interdisciplinary work is sort of embracing that. So it was supported by Dr. Allison Kenner, who's in the Center of Science, Technology, and Society, and Dean Nicholas, who is in COMAD. So I'm going to just tell you what my project is, and then I'll talk to you a little bit about how I got there. It's called Urban Diary, and what it's supposed to do is help people engage in the city that they live in, collect their individual narratives and make it part of a larger cohesive narrative. Because the idea is that if you have a civic engagement platform like this, you help mean creation in the city. That can sometimes be difficult in a non-new setting. If you're more civically engaged, you ideally will want to make the city that you live in better, and we all kind of have a happier, healthier life together. So going back to it not always being this project, this was my senior thesis project, but as part of the custom design major, this interdisciplinary think starting point, but I wanted to be more integrative with the approaches and kind of seeing where there was crossover and where there was more melding happening. So when I started in the major, it was very much about kind of putting these two things together. But beyond that, it's expanded onto thinking about how you can not only think about interdisciplinary in terms of subject matter, but also approaches. Yeah, perfect. Yeah, exactly. So again, you know, it isn't just two separate things. It's how they interact. So I was interested in the environment and sustainability, but I was interested in a lot of things, and I didn't know exactly how I wanted to explore that. So I just kept reading and kept exploring, and I think that one problem with undergraduate research is you can always jump onto a project, but it's a little bit more challenging and intimidating to design your own. Yeah. So as I was kind of thinking about, you know, what should my senior project be and what should I do, I started thinking about sustainability more broadly. There was a lot of research on what does sustainability actually mean, what makes a city, who makes a city, and why is this important? And so I had to be thinking about that. Originally, this project was an anthropological study that was very traditional. You know, it was exploring these topics that I was interested in, but it was doing it in a way that was an anthropological kind of, you know, this is how you do this, and kind of structured that way. We do see crossover in design where people will look at designers and they use anthropological methods. This study kind of flipped that. It was using design inquiry approaches to look at people. So it's a little bit different. It's flipping the script. And it was an iterative process that was very uncertain and very scary. When you change your senior project about 10 weeks out, that is always, your advisor probably is a little scared too. It's hard, but I think having that flexibility and focusing on the process more than the result helped with that. So this is just one screen of the Urban Diary, what it could be. The app, the idea about it would be a digital app, the idea of it is that it would be a place where people can look at stories that are already there and collaborate on maybe those same stories in those same spaces. But ultimately all with the idea of getting people to think differently about their city and connect a little bit more. Yeah, great. So also part of that is creative expression. So not just writing, but all different kinds of people expressing themselves. So again, kind of thinking past what the expectations are for what civic engagement looks like. It doesn't have to just be volunteering at your local community, you know, organization, or it doesn't have to be voting or, you know, whatever our traditional expectations are. So this was kind of looking at what people are already doing in the city, how they're already connecting, and then giving them an outlet of saying, I want to creatively express those experiences. Yep, and then this is just another screen where people could either choose from templates to go into the app and say, I want to choose this template, this is representative of the experience, or they could draw it from scratch. You could either like choose media, upload media directly, you know, stickers, you could draw it. So it was trying to attract all different kinds of people, or different ways that people like to think about their experiences. Oh yeah. So as a research project, it was largely going into these spaces, documenting it, doing field notes, talking to people, lots of interviews, talking to people in city government, so not just the users of the spaces, but also the creators of the space, and then just kind of brainstorming, ideating with different design inquiry practices and seeing what other precedents and use cases were out there. So the next steps for this project to continue on would be, of course, funding, more research. There's always room for more research. Getting a team together of professionals and a facilitator or project lead to help facilitate those skill sets well. And then, you know, continually looking at the vision and the goals of the work, prototyping and re-prototyping, But if there are any immediate clarifying questions that I can answer. Good, I've explained it perfectly.
Thank you, Don. I've been impressed with both of these presentations. Does anyone have any immediate questions for Don? Yeah.
It's not so much a question, but I was hoping you could talk a little bit more about how this is dovetailed with some of the work that I know you've been doing with like Civic Hacking and Code for Philly. So I think they map onto each other so nicely.
They do map onto each other very nicely. So, Code for Philly is a civic hacking group, and they do civic innovations through, they also made me, we do civic innovation through technological solutions. So what Kevin's kind of pointing to is that this is a civic engagement platform. Code for Philly is another way of having that civic engagement, not just in terms of like developing solutions for people to use and be civically engaged, but also for the people who are developing those solutions themselves. Is there anything like specifically you want to talk about?
Well, I mean, was this in some ways a launching point into getting you into that community?
I think that community was a launching point for, and I mean, I think that's true too, right? Like the interdisciplinarity part is, you know, the methods and the research and the content, but then also like life experience and like in the classroom and out of the classroom learning too. So I think, you know, at Drexel having the co-op experience helped to play off one another so that, you know, I was able to integrate all of those experiences and all of that information as a way to kind of develop this. But I definitely feel like my experience with them, I would have never thought to make a mobile app because I'm like not a technical person at all. Who somehow works with technologists, but yeah.
What are you expecting people to do with this app? Like just share their experiences around the city, or like put in complaints about the things that they see on potholes or like?
Well, that app already exists. It's called
Yeah,
Philly 311.
Yep.
Yeah.
I've used it several times.
That's awesome. Yeah, this is definitely supposed to be more creative, right? Because like I am not an artist, but like sometimes there are things that happen that I'm just like, oh, I want to do more than take a picture, but I also want to do more than write like a sarcastic Facebook comment about it or like status or whatever. So yeah, I think it's more about collecting and sort of like capturing and preserving these individual narratives to tell a larger story of Philadelphia. So this is a Philadelphia-specific project, but I think that you could do it. Stories of cities are just so unique, but they're very fascinating, and I think we can learn. I think it's useful as like a civic engagement piece to make cities more livable, but I think it's also informational, both qualitatively and quantitatively, for our government agencies, for developers who might come into the city, and for all the different interests that sort of live in the urban context.
So I have a question that is not yet formulated, so bear with me.
Yeah.
But have you thought at all in the process of this, because you're talking a lot about, you know, civic engagement and connecting with others within the community in which you live, but then you're also talking about a mobile app which needs support like this.
Yeah.
So have you thought about what that gap is and sort of how, if this makes that gap between people larger, or if it bridges that gap somehow?
Yeah, I mean, and I think Anna asked this question during the presentation for my student thesis, is like this question of accessibility. Like, how do we sort of account for that when we're talking about digital platforms? And honestly, I think it's kind of like you have to be able to take what you can get. Like, I kind of know that people, I think it's meant to build into what's already being used. So, like, not to replace Instagram, not to replace Facebook, but to kind of bring those all together and fit into a behavior that's already happening. So if people are already doing that, they're already like this, I mean, I definitely think that it can take people out of the experience, but that's something to keep in mind for as the project will continue to develop. But yeah, it's a good point to bring up. It's just not something that I thought deeply about before, but it's a great thing to figure out, yeah.
Is there anything within this that geotags or in some way connects what somebody is writing or creating with where they are?
Yes, thank you for bringing that up. Ideally, we would have geotagging, again, for the quantitative piece too for us. But yeah, it would definitely be, it's not on this presentation. I actually have, there's a framework that you can kind of map out to see what it would look like. But when you first enter onto the app, ideally, you see a map of pinpoints that show where these stories are happening, and that just gives even more data for us to track.
Yes, I'm thinking through in terms of community groups being able to say, okay, I want to see what people are writing about this particular space or this particular area.
And mapping is certainly part of visual storytelling, which I think that this builds into nicely as well. Yeah, great question.
So I have something that I guess would be for the two of you. So both of the things you presented, they're motivated by environment, sustainability, ecological services, things that I think many of us in this room can agree there is inherent value to. But that's not always true when you're dealing with other disciplines or other scientists or other engineers or other people. So I was wondering how you motivate that. Do we need to bring in other disciplines, or your thoughts on that?
In the case of my particular looking at coastal work, it is for a lot of people who want to see like the values of what ecology and in the context of their lives. I think the most important thing about studying these islands this way is thinking about for some of the beach vacation. If we don't understand these islands, then one day the beach house might be underwater, or they may not be able to enjoy the beach or go safe. So I think that's something that whenever I give this talk to people who aren't familiar with the concepts that's been used.
And I think there are whole disciplines emerging on how you assign that, like how you monetize certain shots, some of those things that would be valued but don't necessarily fit into a traditional optimization.
I mean, I think with this project, apps are sexy, so kind of everyone wants to be part of like the digital realm in a lot of ways, especially researchers from different disciplines, because they're like, this is something that makes my work accessible. So I think it is always important to have those different perspectives when you're doing these kinds of projects. It's just about communicating the value, and not even in an either-or way, but kind of like, I see what your value is, here's how my approach to my research is actually reflective of that. Maybe you didn't know that, but it is. So yeah, I think it's about acknowledging other people's, other disciplines, approaches and goals, and being inclusive by being willing to kind of be more flexible and collaborative and adaptive to it.
I have a sort of a question, comment type of thing. You guys probably know that science is not done in a vacuum today. It's very collaborative and needs to have multiple disciplines, but also multiple organizations. I was wondering if there's other organizations that you might work with, let's say in New Jersey or other parts of Philadelphia, that might help to synergize your work or help move into where you want to go. So for example, in New Jersey, the Coastal Research Center at Stockton College does a lot of work, and I can see like a lot of good symbiosis between this. So I don't know if you have thoughts.
Pretty.
Okay. I mean, in our case, we use the Coastal Research Center a lot. We use that for the mapping. We have to get records of when they put sand on the beaches. But other resources, I know it was the Delaware River Trust or the William Penn Foundation. Helped us. Who was one of the people that funded us? I'm not sure.
Oh, no, so we,
Partnership for
we collaborate, we use some of the data. Dr. Sue Gillum at Drexel is a member of the partnership, so she's one of our advisors. We use a lot of, we use a lot of data, obviously, from the government. We also collaborate. We collaborate with Temple University as well as with Westchester University, and some discussion of talking in Stockton. And in addition to the fact that there has been feelers being put out to talk more to local communities in New Jersey. And that's a little bit more kind of when as the person who's doing the whole project, I've got a little bit more than Nick. Nick has been really instrumental in finding these resources.
Yeah.
Colette, but I think there's been a lot of interest in sort of citizen scientist programs where you can mobilize, especially for like sampling, people pick stuff up, put stuff in bags and stuff like that. There's been a lot of success working with local groups to sort of mobilize people who have a vested interest in this area to help with research.
Yeah, actually, I love since I'm technically working in the paleontology lab here under Dr. Algae, and we do dig data down at the fossil pit in Versailles, just outside of Malton, and we have a recruiting video in September, I think, that's like, usually, right? It's in September, and we had 1,300 people come out last year. So, you know, people from around the community, school groups, and that's a citizen science thing. Sorry.
Yeah, so through our lab, I think it's helped a lot of this, not just with coastal research, but throughout all the research in our lab, so a lot of outreach in addition to trying to collaborate.
And in collaborating with organizations?
Yeah, other groups that might be doing something similar.
Yeah, so kind of, again, touching on the civic hacking community, everything is open source, so it's very much like, it's just a different culture. It's such a, it's a cultural value and it's a cultural norm to share information. It's actually, you're not really part of the community if you are like, this is my intellectual property, no one's allowed to touch it. Like, it's just not really inherent there. So, again, like, it's kind of flipping, you know, like, it's so interesting how those sort of social aspects that you wouldn't even really think about play such a fundamental role in how the profession and how the rest of the tech develops.
And actually, just to kind of bridge those two responses together, I think that this idea of the citizen scientist fits really nicely into what you're talking about, Don, and this idea of building a community of people with shared interests and, you know, shared values in the community in which they live. You know, if you did this in the shore communities of South Jersey, you know, and you had those citizen scientists, if you did something along those lines with some kind of, you know, app that made it accessible, that people could kind of see the development of this data and what it actually means for their daily lives, I think that would be a really interesting sort of marriage of the two ideas that you're talking about here.
Yeah, and I think that's a statement that is kind of speaking to a larger shift that's happening away from silos and away from keeping things totally separate, because design is intrigued by biology. Biologists, you know, can use data and use technology to advance their own goals. So, you know, going back to what I said before, of like showing how we build value into building value for everyone in the end result, I think is kind of like the ultimate result.
Yeah, I mean, yeah, we have people geotagging, you know, saw it in like film today. And it may not be the most exciting thing to everyone else, but it'd be really helpful to us when we go out and catalog that. That's an idea.
I was wondering if also about what would you work for sort of snapshots of time? So a collection at one summer, or if you're, you know, people, it's a snapshot sort of in time. I'm wondering how much you think about how that changes with different for you, different climate events, if it's a seasonal effect or it's just a progressive trend, or how responses to changes affect people's opinion and action.
Yeah, it's a good question. I mean, I think that's also one of the benefits of using this format of a mobile app, is that you can kind of archive things a little bit and have that as part of, you know, here's this story of the city at this point in time, and look at how much it's changed over time. I'm not sure if this is
Yeah, it's just how you fit your work into.
how do you keep it current as things are changing? Yeah. Maybe you want to speak to that at all?
I mean, for us, it's mainly, you know, this having access to this new data is really one of our main reasons for that, because, I mean, it's real time, so I'm getting access, I can just log on to it right now and see what it is we're doing there. But when it comes to the work in general, it's just really looking for collaborators, I think. And what we just, I think Anna just met with someone from Westchester who's does similar work, not in the region, in Marshes. She wants to partner, like sort of take us on and look at that aspect of it as well, to give us another opportunity to get out there and expand our reach.
Yeah, I totally agree. I think that like collaborators in terms of the people who are actually working on it, but then also partnerships outside of that to keep seeing what the new opportunities are, what the new gaps are that are forming. As you're filling gaps, what are the new ones that are opening